Can I play a long animation on the PIMORONI Cosmic Unicorn 32 by 32 LED display board? If I read the data from a USB mass storage device, then I think I can. Let me show you how. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, IoT, robotics and other fun tech. Did you see the digital picture frame that Raspberry Pi placed in their office reception? 576 animated LEDs? Well, I wonder if I could do something similar using the Galactic Unicorn and its Pico W. I didn't want to go down the route of writing custom animations. I wanted to import PNG files to animate on the display, so it's very flexible. These are going to be large, too large to put on the Pico's flash. The Pico's flash is not that easy for me to update and add new animations, so I wanted to load the animations from a USB drive. That will then be super flexible. Please do like the video and subscribe, I do appreciate it.
So the concepts in this video, well, we're going to be working with the Cosmic Unicorn, and we've looked at that in a previous video. It's a 32 by 32 LED display panel that's driven by a Pico W. And I'm going to be pulling in the animation off a USB drive. And we've looked at how you can use a USB drive as storage with a Pico on a previous video as well. So basically I'm just going to bring the concepts from those two videos together and we can display animations. This video is sponsored by Cancun. Cancun is a friendly retailer in the UK for modules, components and electrical equipment. Cancun has kindly offered a discount to my channel viewers on the first order. Just quote Dr. John EA 20 at checkout to get a 20% discount. This excludes electrical test equipment and tools. If you're in the UK, go and check out Cancun today. So the hardware on this project is actually quite simple because all we're going to do is plug a USB drive straight into the USB port on the Pico W on the back of the Cosmic Unicorn. Well, of course, we do need to then think about how we're getting power to the Pico W and to therefore the Cosmic Unicorn, because that USB is the main place of getting power in. Now there is a battery port on the back of the Cosmic Unicorn, and in a moment of complete madness I thought, I can power it via that. But no, of course you can't, because the battery is providing power to VSys. A USB device also needs to get power, and it's connected on VBus. And there's a diode between VBus and VSys, so no power goes backwards. So I had to think of a different way of getting power to it. So I've built myself a little bit of an adapter board, which is basically just two USBs, females connected back to back. And so the powers are connected across between those and the data lines cross between those. So we can plug our USB key into one side of that and the Cosmic Unicorn into that, and the information is able to flow backwards and forwards with that. Then I will use a micro USB cable and adapter to actually provide power so that both my Cosmic Unicorn and my USB key have power. This really should be as simple as using the tiny USB library and the PIMORONI Pico library and bringing those two together to allow us to take animated images from the USB drive and write them onto the Cosmic Unicorn. But of course it isn't that simple, because these two libraries fight, and they fight because there's a DMA channel conflict between the two. So I've had to work out how to avoid that, and the easiest way for that is I can turn off the USB audio on the Cosmic Unicorn, because I don't like or use the audio anyway. So I could remove that, and that removes the conflict. Now doing that isn't necessarily easy. The PIMORONI library does not allow a way of me stopping it from initializing that DMA channel and therefore causing me a problem. So I've actually had to duplicate the code and create a couple of classes called a silent unicorn, which is just some modification of Pimoroni's code. That's a bit annoying. It would have been nice to have found an easier way of removing it and basing myself back against the original code, but I can't. I've had to clone and modify. So the images and the animations we're going to load are basically going to be PNG files using libspng. I'm looking for 32 by 32-bit images, but what I'm basically going to do is stack them vertically one on top of another so that I have basically some 32 by 32 times the number of frames as image size. And then what we'll do is we'll go through and we'll pick each frame out of this rather strange shaped image one by one and then display them on the screen. And that's it. That's how we're going to handle animations. All the code for today's example is of course on GitHub and it's in the project Cosmic Movie. So over in the repo we have my silent unicorn, which is my version of the Cosmic Unicorn and the code that I've had to clone in order that I could remove that audio driver and stop the clash between the Cosmic Unicorn and tiny USB host mode. So silent unicorn is really just using the cloned code and then the bits of the Pimoroni Pico library that I can actually use. So most of it you see is actually coming from the Pimoroni library. I've just got one bit which is in this silent unicorn folder, which is where we're picking up a couple of bits. So if I look in up here, we've got a few files up there and a little bit of code that I've had to modify a bit. Unfortunately, that was the only way to do it and to remove that, but that does work. Perhaps I'll work on a better version of that over time, or in fact do a pull request on my friends at Pimoroni and see if we can enhance this code so that you don't have to remove things to get some of these things to work. We're also using the SPNG library and I've got a makefile for that here as well. SPNG uses a compression library called mini-z and you've got to configure that a little bit to get it to work on the Pico. So there is a port folder in this project and there is a mini-z export.h file where I've configured that mini-z project and library. Let's have a look at main because that's really what's going to do all our work. So in main, let's go right down to the actual main function itself and just talk through quickly what this is going to do. So we are going to initialize the tiny USB host mode. We're going to initialize my disk IO, which is basically my driver for my mass storage IO and how all that's working. And then I'm going to initialize the unicorn. We're going to use the tiny USB host task as I've done in previous examples when I was playing with USB drives, in order that we can actually mount and manage that drive, and it's going to keep calling that. And then I'm going to check for a mount being detected. So whenever something is mounted, what I'm going to do is I'm going to list everything on that drive that is a PNG file using that utility. That's going to get me a vector, and then I'm going to loop through that vector, playing each item PNG file for at least 20 seconds. So if the PNG takes less than 20 seconds, it will restart. So list PNG is up here and is not dissimilar to sorry, let me find it. This PNG. It's up here. It's not dissimilar to the code I showed you directly from Tiny USB's example. It's just a clone of that. All I'm doing is really going through that directory that I've opened and finding all of the PNG files, and when I find PNG file I add its name into my list. That's all we're doing. How about play then, because that's the other intriguing bit, isn't it? How are we going to play? How are we going to put a graphic on the screen? Well, I've got a play PNG file here, and I'm giving it a frames per second that I want it to play at. Or in the example that I'm going to show, I've been playing at about 4 frames per second, which is about as fast as I can read and decode images, I must admit, off of a PNG. So I'm going to open the file, the graphic file that I've got. I'm going to set our library, the SPNG library, into streaming mode. The reason I'm doing that is so that I can take control over what it's reading from and giving it a read function that's going to read nicely from my mass storage code. I'm going to check the dimensions of the image because I can't display anything that's more than 32 pixels wide, because that's the size of our screen. And I use that to also calculate how many frames I think I've actually got in this file. And then we're going to put the decoder into progressive mode, which means I can basically decode a row at a time. And that's what I'm basically doing. I'm just going to keep decoding a row at a time. And then for each row, I then take the resulting data and I place that onto my Cosmic Unicorn. And when we get to the end of the last row, we can then update the Unicorn and get it to display that. And then we move on and we do that cycle by cycle. There's a little bit of timing in here as well, just to help it slow down so that it's actually going to the frame rate that we've set. As soon as you realize how you can actually decode a PNG, it's actually really simple to copy that over onto the Cosmic Unicorn. Now, this of course function does of course rely on the fact that we can read from the mass storage device. Where's that read function? Well, that's up here. It's SPNG read, and this is just mapping really the read required by the SPNG library to the read provided by our FAT file system driver. We've got 2 other bits of code in here that I guess are important, well actually are important. The tiny USB host mount code is all detecting the mount. So this has got all of the callbacks of what happens when a mount is detected or an unmount is detected and the handling of that. So I splat that out into a nice little separate module because it's clearer to me and more reusable for me as well. And I've done similar things with the disk imp, which is basically the mapping between tiny USB's host functions for talking to a USB device and the FAT file system code and driver. So that gives you that mapping to allow us to actually talk to this drive as if it is a file system. Final thing to notice, mention I guess, is if we have a look at our makefile here and look down here, we've got no standard I/O available to me at all because I can't put standard I/O over USB, and I've got no UART of ports available to me on no GPIOs available really for UARTs on the Cosmic Unicorn. So you are writing this code sort of blind, which is not ideal, and this makes the actual development actually quite tricky. But we got there and we got the code. So let's have a look at some of the demos of it. So to generate my PNG files for these animations, I've been using Blender and not necessarily very successfully trying to render images down to 32 by 32 pixels. These are quite small sizes really for trying to do anything that's actually 3-dimensional graphics, but has some reasonable effects. I mean, so here's a simple cube rotating, which doesn't look entirely effective. Then this is Jupiter, which looks a little bit better. The colour definition comes out a lot better in reality than it does over the camera, I must admit, so apologies for that. I guess the best image that comes out so far that I've been playing around with is a rendering of the Earth, probably because it's got a little bit more colour saturation and depth into it. I think, you know, if you hand-coded your PNGs to be animated, you probably get a slightly better quality output than I'm getting at the moment. But it is quite nice, the fact that I can actually generate something from a utility like Blender and then just copy it onto a USB key, and it's there for my Cosmic Unicorn to display.
Right now, I'm just playing whatever files the Pico finds on the drive. Of course, I could be more specific and play particular animations based on particular cues. The files I've demonstrated are up to 250 kilobytes in size. We certainly could not have that many of them on the internal flash on the Pico W, so that USB drive really helps. Thank you very much for watching. Please like the video as it helps encourage me to make more videos, and please subscribe and hit that notification button to avoid missing the next video. Goodbye for now.